Hello friends, welcome to Learner's Planet. Friends, this is our second session for probability. In the previous session, we discussed the basic terminologies related to probability, maybe random experiment, maybe sample space, various types of events like mutually exclusive, mutually non-exclusive, independent events. And we did some problems based on dice and cards. In this session, we'll be taking problems based on all these concepts. So let's begin the session. Dear friends, now I will like to take some cases of dice, right? Now suppose we have two dice and we have to make various combinations of numbers, right? Now in each dice there are six dots, right? Now we have to find out the sample space when the sum of digits which are appearing on the dice is 2, right? Sum is 2, 3, 4, 5 till 12. So we have to make all the combinations, right? Now when the sum is 2, that means on both the dice number 1 and 1 is appearing, right? Sum is 3, that means 1, 2 and 2, 1, right? On the first dice number 1 is there, on the second dice number 2 is there, or on the first dice number 2 is there and the second dice number 1 is there, right? So there are two ways of making the sum of digits as 3, right? Similarly 4, if we see, it's 1, 3, 2, 2, 3, 1, right? Similarly 5, that's 1, 4, 2, 3, 3, 2, 4, 1, right? For 6, 1, 5, 2, 4, 3, 3, 4, 2 and 5, 1, right? For 7, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. Okay. Similarly for 8, now we cannot use 1 because on the dice maximum number is 6. So we have to start with 2 now. So it's 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2, right? Similarly 9, it's now we cannot even use 2, 3, 6, 4, 5, 5, 4 and 6, 3. So 10, it's 4, 6, 5, 5, 6, 4. Similarly 11, it's 5, 6, 6, 5, and for 12 we have just a single combination, that is 6, 6, right? So we wrote all the combinations possible when we are throwing two dice and we are taking care of the addition of the numbers which are appearing on the dice, right? So this is 1, so 1, it's 2, 3, 4, 5, 5, 4, 3, I'm sorry, just 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, it's 6, then it's 5, 4, 3, 2, 1. So these are the sample spaces for each number, right? Now let's discuss various questions based on this. Suppose we have to find out the probability when we are throwing two dice and the sum of digits which are appearing on the dice is 3, right? So in all, how many cases we are having? See, total, if you add up all these numbers, all these combinations, in all it will be 6 into 6, that is 36 combinations will be there, right? Because Sample space of first dice is 6 and sample space of second dice is 6. So in all, the sample space will be 36, right? So we are having 36 combinations over here, right? Now how many of these combinations are making the sum as 3? That is 2. That is 1, 2 and 2, 1, right? So what is the probability of getting the sum of the digits as 2, as 3 is that 2 by 36. Right? Similarly, if we have to find out the sum of digits to be 10, then it's 3 by 36, right? If we have to find out the sum of the digits to be 7, then it's 6 by 36. If we have to find out the sum of the digits to be 6, then it's 5 by 36. So we can easily calculate that once we are clear about all these combinations, right? Now, the next question which we can frame is, suppose we have to find out the probability of the event when I'm getting the sum more than 10, right? Sum of the two digits that which are appearing on the dice is more than 10. So if the sum is more than 10, that means there are two possibilities only. That means sum should be either 11 or 12, right? So the what is the total number of combinations over here we are getting for 11 and 12? That's 2 plus 1, that's 3, right? And what is the total number of events? That's 36, and favorable events are 3. So 3 by 36 is the probability of getting the sum on of the digits of both the both the dice more than 10, right? Similarly, if we have to calculate for less than 10, then this will be more than 10. This is for 10. So the remaining cases, that is 3, 4, 5 and 6. That means the 30 cases will be there when the sum is less than 10. Right? Now this is more than 10, this is less than 10. If we are asked about more than equal to 10, then we'll be taking this 3 also, because more than equal to, this is more than 10 and this is equal to 10. So in that case it will be 6 by 36, right? Or if it is less than equal to 10, then we have to add 3 over here, because less than is 30 and equal to is 3, right? So we have to be clear about more than, equal to, less than and less than equal to, right? Now suppose we are asked what is the probability of getting sum at least maybe 7, right? If at least 7 is there, that means the sum should be 7, 8, 9, 10, 11 and 12, right? At least 7. So how many combinations are there? It's 6 plus 5, 11, 11 plus 4, 15, 16, 17, 18, 19, 20 and 21. So the probability of getting the sum at least 7 will be 21 by 36, right? So it's at least. So you got the difference between at least, more than, equal to, less than, equal to, right? Now the next question which can be framed over here, that the number which is appearing on both the dice should be same, right? That means same number should appear on both the dice. That means we have to select the combinations as 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6. So in all there will be 6 combinations. So the probability of getting the same numbers on both the dice will be 6 by 36, right? Now if the question is there, the sum which is appearing like the sum should be maybe a prime number, right? Now we have the prime numbers as 2, 3, 5, 7 and 11 over here. Now for 2, how many cases are there? 1. How many combinations are there? We can say for 3 we have 2 combinations, for 5 we have 4 combinations, for 7 we have 6 combinations, for 11 we have 2 combinations, right? So these are the prime numbers and we are having these many combinations which are giving us the sum as prime numbers, right? So in all, that is 6 plus 2 8 plus 4 12, 12 plus 2 14 and 1 15 by 36, right? So these are the cases or favorable cases when the sum of digits appearing on the dice is a prime number, right? Similarly, friends, various questions can be framed, right? I just take 1 or 2 examples. I'm not just not going to solve them. I just giving you the examples only. Sum of digits should be even. Sum of the digits should be odd. Sum of digits should be multiple of 3. Sum of digits should be multiple of 5. right? Various questions can be framed, right? Now I take one more question. Sum of digits should be either multiple or 2 or 3, right? If this is the question, sum of digits should be either multiple of 2 or 3, right? So first of all, we have to discuss this. Which type of event is this? I just write down the question over here. And the question is sum of the digits or number whatever should be multiple of 2 or 3, right? Now or and what's the difference, right? If we take and, that means 2 and 3, that means the number should be multiple of 2 as well as 3, that means the number should be multiple of 6, right? So how many combinations are there when the number is multiple of 6? That is 6 and 12. For 6 we have 5 combinations, for 12 we have 1 combination. So in all there are 6 combinations out of 36 when the sum of digits is multiple of 2 and 3 both as well. That means precisely the sum of digits is multiple of 6. So that's what and. In this case we are asked about 2 or 3. That means the sum which is appearing or sum of digits which are appearing on the dice is either multiple of 2 or 3, right? So what are the various combinations? So combination for 2 is like what? It's 2, 4, 6, 8, 10 and 12. Combination for 3 is what? 3, 6, 9 and 12, right? So first of all we'll find out the probability of the sum of digits is multiple of 2. So suppose I take it as P2. So I have to add all the combinations for 2, 4, 6, 8, 10 and 12, right? So I just add them. So for 2, I just write it over here. 1 plus 3, that's 4. 4 plus 5, 9. 9 plus 5, 14. 14 plus 3, 17. 17 and 1, 18, right? So in all 18 combinations are there when sum of digits or sum of numbers is multiple of 2, right? 18 by 36. The probability will be 18 by 36. So I write here 18 by 36, right? Now I take probability of sum to be 3. So I take it as 3. So here I am going to find out the combinations where the sum is 3, 6, 9 and 12. So for 3, I just see the table. So 3 is, this is 2, then plus 5, 5 plus 2, 7, 7 plus 4, 11, 11 and 1, 12, right? So 12 combinations are there which are giving the sum of numbers as multiple of 3, right? So it's 2 plus 5, 7 plus 4, 11 and 1, 12, right? So I write 12 by 36 over here. Now probability of sum divisible by 2 is 18 by 36. Probability of sum divisible by 3 is 12 by 36. So 2 or 3, the probability will be 18 by 36 plus 12 by 36. Now what's happening over here? Just look at over here. 6 we have counted here also and here also. Similarly 12 we counted here and here, right? So we cannot calculate 6 and 12 for 2 times, right? So we need to deduct the combinations of the number which are multiple of 2 and 3 both as well, right? So that's what probability of 2, this what probability of 3, and we need to deduct the probability of 2 and 3, right? That means the combinations in which the numbers appearing are multiple of 6, right? So how many combinations are there? We have 6 and 12. For 6 we have 5 combinations, for 12 we have 1 combination. So in all 5 plus 1, 6, right? So once we have deducted 6 and 12, so now we are getting the correct answer. Okay, so it's 18 plus 12, that is 30. 30 minus 6 is 25 by 36. In all, the probability when the sum of numbers is either divisible by either 2 or 3. Right? I hope you are clear. Now the next question over here, that sum of digits should be either an even number or a prime number. Sum of digits or number be an even number or prime number. Right? Now we have even number as 2, 4, 6, 8, 10 and 12, and we have prime numbers as 2, 3, 5, 7 and 11. Right? So we have to calculate the probability of an even number, we have to calculate the probability of a prime number, then we have to deduct the number, the combination of even prime number, that is number 2. Right? So I hope you can do this problem. This is quite similar to the previous one. That's probability of getting an even number plus probability of getting a prime number minus probability of getting even and prime. Right? So you have to deduct the probability of number 2. That is sum when the sum is 2. Okay. So this was the example of mutually non-exclusive event. Yeah, right. So we discussed mutually exclusive event. We discussed mutually non-exclusive event. Suppose I tell you the number should be maybe either odd or even, right? So it will be a mutually exclusive event. I'm sorry, because the number which is odd cannot be even and the number which is even cannot be odd, right? So this is the example of mutually exclusive event. So mutually exclusive, non-exclusive and independent. One more example, suppose the sum of numbers should be multiple of either 3 or 7. So this is also mutually exclusive even because the number which is multiple of 3 cannot be multiple of 7 and the number which is multiple of 7 cannot be multiple of 3. As simple as that, because we are getting the sum of digits at max is 12, right? So we do not have 21, so we don't have to worry. It's a mutually exclusive event for a dice, right? Now suppose I just take the example of independent event. Maybe I'm throwing in the first step, I'm just throwing one dice only, right? And I want the number should be maybe an even number, right? So when I throw the dice for the first time, I want the number to be an even number, right? So first, in the first throw, I want an even number. In the second throw, I want a prime number, right? That means I'm throwing the dice for 2 times, right? I'm not throwing the 2 dice simultaneously. I'm throwing a single dice for 2 times, and the first time I want an even number and the second time I want a prime number. Now these 2 events are independent events. Why they are independent? Because whatever the result you are getting and the first throw, it doesn't make any impact on the second event, right? So whatever the number you are getting on the first event, it's nothing to do with the number that you are getting on the second throw, right? So both of these events are independent events, right? So what will be the probability of that? So in the first throw you want an even number, so what's the probability of getting an even number? There are 3 even numbers, that's 2, 4, 6. So the probability will be 2 by 6. And in the second throw, see here just one dice is there, that's why I'm just taking denominator as 6. Now in the second throw, total cases are 6 and the prime numbers are 2, 3 and 5. So we are having 3 cases here. I'm sorry, it's 3 even numbers are there. So 3 by 6 into 3 by 6, that is 1 by 2 into 1 by 2. So the probability will be 1 by 4. Now these 2 events are independent events, right? Okay, so we discussed the 3 cases over here: mutually exclusive, mutually non-exclusive and independent events, right? So I hope you will be clear now. Now similarly we can take various cases of cards as well. We'll be solving the questions, but as of now I just wish to discuss the basic questions, so while we go for multiple choice questions you'll feel comfortable, right? Now what's in all in a deck? 52 cards are there, right? And there are four types of suits, that is spade, club, hearts and diamond, right? 13 of each type, right? And there are 4 ones, 4 twos, 4 threes, 4 fours, and till this jack, king and queen, right? All these are also 4. So these are like face cards, or you can say picture cards, whatever. So 4 4 4, there are 12 picture cards in a deck of 52 cards, right? And 4 s's are there, 4 like whatever you say, ones or s's, or maybe twos, threes, fours, 5 6, right? So in all 13 13 13 13. Okay, now these two are black cards and these two are red cards, right? That means there are 4 jacks, 2 jacks are black and 2 are red. Similarly 4 kings are there, 2 are black, 2 are red. Similarly 4 queens are there, 4 2 black, 2 red. Similarly all other cards are 4 in number and 2 are black, 2 are red. Okay, now let's discuss various questions which can be framed over here. And again we have to consider the various types of events, that is mutually exclusive, mutually non-exclusive and independent events, right? I just take an example and you just think which type of event is this. Now the very first question is, suppose I am drawing a card from this 52 cards and I have to find out the probability that this card is either 4 or jack, right? I have to find out the probability of either 4 or jack. First of all you have to judge whether this is mutually exclusive event, non-exclusive event or independent event. So just think, the number which is 4 cannot be jack or jack cannot be 4, right? So this is mutually exclusive event, right? That means we have to find out the probability of 4 plus we have to find out the probability of getting a jack. Now how many fours are there? That's 4 fours are there. So out of 52, 4 fours are there. So this is the probability of getting a 4, or for that we'll be using plus sign. How many jacks are there? It's 4 jacks. So it's 4 by 52. So in all it's 8 by 52, right? So this is the probability of getting either 4 or jack, right? Now here in this case I just draw one card. Now in the second case, suppose I am drawing a card. It should be maybe either a jack or a picture card, right? Jack or picture card. Now which type of event is this? What is the probability of jack? It's 4 by 52. What is the probability of picture card? How many picture cards are there? 4 jacks, 4 kings, 4 queens. So it's 12 by 52. Now jacks we have counted over here and jacks in the picture card also. So jack is being counted for 2 times. So we need to deduct it at 1 time, right? So we need to deduct the combinations of jack and picture card. So that will be 4 by 52, right? So in all the probability will be 12 by 52. Okay, getting my point? And you must be getting the difference as well. Now further, I just take another example. Now I am drawing 2 cards, right? First of all I draw one card, then once again I draw other card, right? And one card should be maybe 4 and the other card should be a picture card. Right? Now I'm drawing two cards. First of all, I draw one card and then I draw the other card. Now in this case also various types of events are there, right? Just listen to me very carefully. It's one card and is the other card, right? Now there are various types of cases. What is the first one? That's first of all, whenever you are drawing the card, that you are drawing from the 52 cards, right? So when you draw one card, the second card will be drawn out of 51 cards. You should be careful about it, right? So there are two words, that is with or without replacement, right? Without replacement means what? Suppose you draw the first card, that means, and you are not putting that card back to the deck, right? That means the second card will be drawn from the 51 cards only, right? That's called without replacement. Now what's with replacement is that first of all you are drawing a card, you just see it and you just put it back into the deck, right? So the second card also will also be drawn out of 52 cards. So that's with replacement. So you should be clear with the both the terms, that is with replacement and without replacement, right? So if you are not clear, your answer you may arrive at wrong answer, right? Now here one card should be 4, right? Now what's the probability of getting 4? That's 4 by 52, right? And the other card should be picture card. Now what's the probability of picture card? That's 12 by 52. Now as I told you, the possibility is with or without replacement, right? So here I haven't mentioned that I should put the card back into the deck or not, right? So I'm just going to discuss both the cases. First of all, I'm just putting whatever the first card was there, I just saw it and put it back into the deck, right? So the probability will be 4 by 52 of this 4, and probability of picture card is 12 by 52. Now since we are drawing two cards at different timings, both the events are independent events, right? That means in the first go, whatever is coming has nothing to do with what is coming in the second draw. So both the events are independent events. So it's 4 by 52 into 12 by 52 will be our answer. It's with replacement. That means both the cards we are drawing from the 52 cards only, right? And the second question is, suppose we are not putting back the first card, right? That means the first card will be drawn from the 52 cards. That's 4 by 52, and the second card will be drawn from the 51 cards only. So it's 51 by 12 by 51, as there are 12 picture cards. Now again there is a twist. We are asked that one card should be 4 and other card should be picture card, right? But we are not told that the first card should be 4 and the second card should be a picture card, right? So we have to consider both the events, that is first is 4 and second is a picture card, or first is a picture card and second is a 4, right? So both this is an independent event, this is an independent event, but either of the event can happen. These combinations are mutually exclusive, right? In this case, we are getting 4 on the first draw and picture card in the second draw. In this case, we are getting picture card in a first draw and 4 in the second draw. So either this or this can happen. Okay, so this is independent event, this is independent event, and overall this is mutually exclusive event, and we have to be careful about both, right? If the question is that the first card should be a 4 and the second card should be a picture card, then only this answer will be there, right? Just be very clear about both the incidents. If one card is 4 and other card is picture card, then we have to consider both the cases. If first card is 4 and second card is a picture card, we have to consider this case only. Or if first card is a picture card and second card is a 4, then we have to consider this case only, right? So be very clear about it, right? Precisely, in short, we can do this calculation by, we are drawing 2 cards out of 52 cards, so the combinations will be 52 C2, and first one card will be this 4 and the other card will be picture card. So in this case, both the incidents have come. Getting my point? If you just open it, you will be getting the sum like this only. So it's 4 into 12 into 2 by 52 into 51. Right? So it's 4 into 12 2 times by 52 into 51, right? So we are getting all the combinations of 2 cards for 2 simultaneous draw, right? So I hope you are clear with some basic questions of cards and dice. In the next session, we'll be taking more questions, more concepts. Do revise this session and the previous session, and it's really important to revise the sessions of permutation combination. Okay, bye bye.